Migrating the game state methodology into the catcher game requires paying attention to a couple of small details and also determining what is the criteria by which one will either win or lose the game. So the first thing that I need to make sure I do on this is I already have a score in my catcher game. It just doesn't do anything except keep track of that, but I do need my game state, so I will grab a copy of that, stick that over in my project. I will grab the information about my game state to bring into my setup, and I can put that in there. The next thing that I want to do is I'm going to grab my game state loop that I have here, copy that, and then I can put that in. Clear background is not going to be there anymore because we will manage clearing the background as part of each game state, because then we will take care of it there. The next thing that we need to bring into this is we have our different states that we're looking at, our start state function, our play function, our win and lose function, so we need those. Now the contents of the play function, that's all going to pretty much go away and be replaced by what's in the catcher game, but in the interest of not having to retype a lot of things, I am going to go grab that information and paste it in to my project. So I'm putting it between the end of draw and clear background. It's not a bad idea on the closing curly brace for each function, add in an end statement, so then when you are copy pasting things in, you know that this is an ending statement for a particular function. It allows you to not paste a function into a function. So I'm even going to go through and do that right now to help keep track of what I'm doing here. So having these end statements in does help as part of the organization as we're trying to keep track. Another thing that helps is having line returns between them. So now in the previous the information we grabbed over from the states with the duck, we no longer are going to care about anything related to the duck. Now what this does have, and we will want to figure out how we're incorporating it, is it does have criteria of how does someone win, how does someone lose. And that is something that we will figure out for the catcher game in a moment. Just put in a few extra returns to add in legibility so we can see what is happening. Now inside the play state, that is really where all of this information about clearing the background, managing the drop timer, the catcher, active drops, all of that stuff that was part of the original draw function. Oh, and score. I forgot to grab those, so let's copy again. So I will cut that out of draw. So now draw is short, just like in the duck one. The draw is just simply managing the state. Start hasn't changed. We'll put the catcher game stuff under play. So now under play, we clear the background, drop timer happens, we update the catcher position, we manage what's happening with the drops. So if our score is greater than 10, we'll set our game state to win, and we will worry about losing in a moment. So now if I win, we can see then it's going to call the reset game state, and under reset, it reset the score, put it back to start, so we can run this now and see. So now we're in, it might be useful to put some text on the screen here so we know versus more than just simply the blue background color. And now let's see, I have to, I think, catch 10, and I won. So now I won. I'm going to just go into these different states here. And just put a little bit of text on screen. You lost. And then we can, remembering our lessons on putting text on screen, when we put text on screen, often what we need to pay attention to is the alignment of the text, the position of the text, the size of the text. So if I set my x at my width divided by 2, put the height, we'll just put it up at 200 for now. We'll do a text align. Actually, it's text align center. Now when we're showing the score on screen, now we'll have our text align left. I put that under loss. That's not really going to help too much because we can't lose yet, but we will put that under win as well. One. And then even on the main starting screen, now when we run it, we'll have some text on screen. The size is a little bit small, so we probably need to boost that, but we can play. And 1, get to play again, score reset. But we do see that the objects aren't resetting. So eventually, if I were to play this, I would run out of objects to catch because there's only 100 drops. And the drops are putting themselves on screen. And now I can cheat the system by, because the drops are in screen, if I move my catcher object up there, I can get the score very quickly. So it's not a very challenging game as of yet, and we have to figure out how to lose. Game, when the duck got greater than the width of the screen, it changed our game state to lose. But that's not really applicable to our catcher game. But right now, if we look at the drops, when the drops are falling, if a drop is caught by the catcher, our score goes up. If our score is greater than 10, then we win. So now if we look at it, we want to figure out how to set that game state to lose. So we can check collisions. That determines if we have lost. We could set it up that if just one single drop goes off screen, then we lose. So this is just one of, it's however you want it to be. But if I say that, okay, if it goes off screen, I lose. So if drops, so the drop that we're looking at, so we are cycling through every every tick of the frame, so 60 times per second, we will go through all of the active drops, so the drops that are moving on screen. We update their position, we update their display, then we find out have they intersected with the catcher. If so, that it makes the drop caught and it sets our score. But if the drop's Y value is going to be greater than height, that would indicate that the drop has indeed passed below the bottom of the screen. So when that occurs, we can now set our game state equal to lose. And in doing so, that will automatically kill the game if just one single solitary drop falls below the bottom of the screen. So now let's try this. Play the game, we'll let one fall, and I lost. Now I can play again, and we'll see that one of the problems that's happening is now every time the game starts up, the drops are exactly where they left off. So that's a problem. And this is where we need to build in that reset. So we have this reset that we are looking for, where that resets the score. That's good. So we don't automatically keep winning every time we push the button. But we haven't reset the drops. So we have to reset the drops so that they're no longer running exactly where they were before. We also need to reset on it active drops, because active drops every, what is it, where's our drop interval? So every 200 milliseconds a drop starts falling down. So 5 drops per second are falling on screen. And if the game played for a number of seconds, now we have a bunch of drops that are all falling. Active drops is going to be somewhere between some number and 100. So we need to reset active drops as part of our game as well. So if I set my active drops equal to 0, now we will find an interesting thing is going to happen. So I'm going to just let the drops fall. I'll lose the game. Okay, I lost. Now I reset, and we can see that it's resetting active drops, but the drops are still wherever they were on screen, so that's not helping. But if I look in my drop class, I will see the drop is waiting for me to call a reset on it. Now when a drop is created, it gets put at a random position. Its Y starts out at 0, and its speed is a random number. So when I reset a drop, I don't care about R, but I do care about those 3 things. So I'm just going to copy that. And when I reset a drop, because when I catch a drop, I kill its speed and I kill its Y. But when I reset a drop, I want to put it to a new position so the drop appears to be different. So it doesn't appear that we have 100, but appears that we have an infinite number of drops. We'll reset their Y speed so they can fall again, and reset their Y to 0 so that they dump themselves back off the screen. Now if I run the game and play, when it resets, so we've added in our reset state. We haven't actually used or done much with it. Now we have. Active drops have been reset, but now we have to go through all of our drops and it's safest to just go through all of the drops. So then we use drop.length as our range that we're working with, and then we will tell each individual drop to call its reset method. So while the drop, we can use the drop reset method, we actually have to call it for it to do any good, because just putting it in the class so the drop knows how to reset itself, that's great, But if we never tell it to reset itself, it's never going to reset. So now, if I play, let's lose, boom. And now the drops start again from the top. And we'll prove that win works as well. If I can get 10, hey, I won, and the game starts over. So we've set a criteria. In this case, the single criteria is if a drop hits the bottom of the screen, I lose. That's one way of doing it. We could have two kinds of drops, so that I could have a drop I need to not touch versus drops I touch. That would be another way. We could set down a timer so it counts down after so many seconds. If I haven't caught the required number of drops, then I lose the game. There's a number of ways. It's all based on how you want to build it into your gameplay.